Welcome to this HP Technical Configuration Guide. In this TCG, we're discussing HPE and Cisco OSPF interoperability. I'm going to explain and demonstrate the configuration of multi-area OSPF on HP switches running the Provision operating system and Cisco switches running Cisco iOS. This TCG consists of two parts. In this first part, there's an overview of the interoperability of HP Provision and Cisco switches, including guidelines, command explanations, and show commands. The second part is a practical demonstration of the configuration and testing of HP Provision and Cisco switches running OSPF. For a quick explanation, continue watching Part 1 and then continue to Part 2 to watch a practical demonstration. The topology used in this video consists of 4 switches, 2 HP switches HP1 and HP2 running the Provision operating system, and 2 Cisco switches, Cisco 1 and Cisco 2, running the Cisco iOS. The devices have already been cabled up and configured with IP addresses. HP1 and HP2 are configured with IP addresses in VLAN 1, and they are connected using port 1, and will be configured in OSPF Area 1. The Cisco switches have their ports configured as routed ports, so the interfaces, Gigabit 101, have IP addresses configured directly on them, and these switches will be configured in OSPF Area 2. HP1 has interface 2 in VLAN 10, configured with an IP address, and Cisco 1 has interface 102 configured as a routed port with the following IP address. HP1 and Cisco 1 will be configured in Area 0. Thus both HP1 and Cisco 1 are ABRs or area border routers, as they have interfaces in multiple areas. The HP switches used are 3500YL switches running Provision operating system K1447. The Cisco switches are 3750s running version 12.255 SE1 supporting IP services. OSPF, or Open Shortest Path First, is an open standard link state routing protocol. Neighbors form adjacencies before routes are exchanged. OSPF hellos and neighbor establishment uses the link local multicast 224005. For peer or neighbor relationships to form, 2 routers have to be directly connected at layer 3, as they are using a link local multicast. Now, as always, there are exceptions to the rule. So exceptions such as virtual links and GRE tunnels are not covered in this TCG. In this TCG, we're assuming that 2 routers or 2 layer 3 switches are either directly connected or are connected via a layer 2 device, thus having direct connectivity at layer 3. The routers have to be in the same subnet, using the same mask. They need to be configured in the same area. Hello and dead intervals need to be configured the same authentication method, either no authentication, clear text, or MD5 authentication, needs to be configured on both routers, and the same authentication information, such as the password, need to be the same. In addition, the stub flag needs to be set on both sides. In other words, if the area is configured as a stub or totally stubby area, all the routers in that area need to have that configuration set. Otherwise, neighbor or peer relationships will not form. The same MTU needs to be configured on both sides, as well as the network type. So for example, broadcast or point-to-point. If peer relationships are not being formed between an HP and Cisco switch or router, ensure that the routers are directly connected and that these configuration options are the same on both sides. In OSPF, each router or switch is uniquely identified by a router ID. So each device in the OSPF domain needs to either be statically configured with a unique router ID, or a router ID will automatically be chosen from one of the IP addresses configured on that device. It's recommended that you configure a router ID manually To do that on a provision switch, type enable, conf-t, IP router ID, and specify the router ID. In Cisco, enable conf-t, configure OSPF by using the command router OSPF and specifying a process ID. I'll talk more about process IDs in a moment, and then configure the router ID. The router ID once again needs to be unique on all routers in the OSPF domain. I'm now going to explain the configuration of OSPF on provision and Cisco devices and the enabling of OSPF on specific interfaces in specific areas. Once I've explained the basics of OSPF, I'll show you a full configuration, including the router IDs. To enable OSPF on HP provision switches, in this example HP1, type enable, conf-t, enable IP routing. IP routing is not enabled by default. Enable OSPF by using the command router OSPF. Create your areas. In this case, we need area 0 and area 1 configured on HP1. Provision switches do not support routed ports, so enable OSPF on the VLANs. In this case, IP OSPF area 0 enables OSPF area 0 on VLAN 10. The command IP OSPF area 1 enables OSPF on VLAN 1. Make sure that you select the VLAN and then type IP OSPF area and the relevant area. So once again, VLAN 1, IP OSPF area 1. On newer versions of HP provision software, OSPF has to be explicitly enabled. So to do that, we're going to type exit to go back to global configuration mode, and then type the command router OSPF enable. On older versions of provision, this was not required, but if your OSPF relationships are not forming, ensure that you've enabled OSPF on the switch by typing router OSPF enable. To enable OSPF on HP2, type enable, conf-t, IP routing, router OSPF, configure your area, in this case area 1. Go onto the VLAN, so VLAN 1, and enable OSPF in the area on that interface by using the command IP OSPF area and the relevant area number, in this case area 1. To enable the OSPF process on the switch, type exit to go back to global configuration mode, and then type the command router OSPF enable. This will enable the OSPF process on the device. To do something similar on the Cisco devices, in this case Cisco 1, you type enable, conf-t, enable IP routing. IP routing is not enabled by default on Cisco switches. It is enabled on Cisco routers by default. So in this case, because we're using a 3750 switch, we need to firstly enable IP routing and then specify the OSPF process by using the command router OSPF and a process number. Once again, the process number is locally significant and doesn't have to be the same on all routers. So I'm going to use process number 1. OSPF is then enabled on interfaces by using the network command. So network 10.1.10.2, the IP address on interface gigabit 102, an exact match on the IP address, and specifying the area. So this command enables OSPF on this interface because it has IP address 10.1.10.2 configured on it. You could also use the subnet address, so network 10.1.10.0 with an inverse mask. So we are matching 10.1.10, but the last octet can be anything, and enabling OSPF on any interface that falls within that subnet. OSPF can also be enabled on all interfaces by using this format. This is not valid in this example because we don't want all interfaces to be in area 0. This interface needs to be in area 2. So this command is not used in this example. Cisco devices also allow you to configure OSPF in a similar way to provision devices where you go onto the physical interface if it's a routed port, or the VLAN interface, and then enable OSPF by selecting the process number and area number on that individual interface or VLAN interface. To enable OSPF on Cisco 2, you would type enable conf-t, enable IP routing. On Cisco 1 that's been done already, but you need to configure that on Cisco 2. Enable OSPF with a relevant process ID, once again can be different on different devices. And then enable OSPF on the interface, in this case gigabit 101, by specifying the IP address with an exact match on that IP address, and specifying the area, in this case area 2. You could also enable OSPF by specifying the network with a wildcard mask. So any interface configured in subnet 10.1.2.0 will have OSPF configured on it in area 2. Something similar would need to be done on Cisco 1. In this case, you could specify the individual IP address as 10.1.2.1 or configure it in the same way by specifying the subnet. So here's the full configuration. In this example, let's start with HP1. On HP1, enable IP routing. Specify the router ID. Configure OSPF. Create areas, area 0 and area 1. Enable OSPF in area 0 on VLAN 10. Configure OSPF in area 1 on VLAN 1. Type exit and then enable OSPF. On Cisco 1, enable IP routing. Configure OSPF with the process ID, in this case process ID 1. Specify the router ID. Enable OSPF on gigabit 102 in area 0. Enable OSPF on gigabit 101 in area 2. On HP2, enable IP routing. Configure a router ID. Configure OSPF. Create the areas, in this case area 1. And then enable OSPF on VLAN 1 in area 1. Enable OSPF. On Cisco 2, enable IP routing. Configure OSPF with the relevant process number, in this case process 1. Configure the router ID and then enable OSPF on gigabit 101 in area 2. Process IDs are locally significant and can be different on various routers. Router IDs need to be unique throughout the OSPF domain. Here are some useful show as well as debug commands to help with the troubleshooting of OSPF. In Part 2, we'll discuss these commands in more detail, but as an example, to ensure that OSPF is enabled on an interface, use the commands show IP OSPF interface or show IP OSPF interface brief. To ensure that OSPF peer or neighbor relationships are established, use commands such as show IP OSPF neighbor. You can also use ping and LLDP to check connectivity between neighbors. Debug commands such as debug IP OSPF adjacency and debug IP OSPF packet allow you to check OSPF messages in real time. Once again, in the second part of this TCG, we'll discuss the show and debug commands in a lot more detail, and I'll demonstrate the output of the debugs. That concludes this first part, discussing the configuration of OSPF on HP Provision and Cisco switches. In the second part, we'll continue the discussion with a practical demonstration of the setup and testing of OSPF on HP Provision and Cisco switches.